film. Okay, so just a little bit about the basics of organic chemistry. There's allotropes. These are allotropes of carbon. All the green atoms represent carbon, and we've got the difference is how they're bonded. So we've got diamond, one of the hardest substances on Earth. We've got graphite, which is pencils, and then we've got Buckminster fullerenes, also known as fullerenes or buckyballs. And those are pretty cool. Those are naturally occurring. They're kind of look like a soccer ball in soot from the incomplete combustion, say, of wood. So that's why it gets trapped in your furnace. Organic compounds, really the definition of an organic compound is made of carbon. More than most of them have hydrogen in them as well, and then some of them will have oxygen and some other elements. So a couple things, structural isomers. For example, C4H10. We're going to be drawing organic molecules and naming them, and I'll show you how to do that. But first of all, a couple things you need to know is that, first of all, carbon, because it starts off with 4 valence electrons, it's going to make 4 bonds. 1, 2, 3, 4. And so that way you can determine how many hydrogens each carbon will need. So that's the first thing you need to know. Carbon is always going to make 4 bonds. Okay, so it could be 4 single bonds like this. It could be a double and 2 singles. It could be a triple and a single, etc., etc. Now, these can be combined in different ways. For example, we can put 4 carbons in a line with the 10 hydrogens around them. Or there can be 3 carbons and another carbon coming off, making a different compound. And sometimes they can have wildly different properties. And but they both have the same formula, C4H10. So they can always want 4 bonds. There's some things called geometric isomers, and really they just have different geometry. We're not going to deal with that much. And so here's what we're going to use for today. Alkanes. These are saturated. Okay, saturated means full. Now, what they're saturated with is hydrogen, meaning they have the most hydrogen they can possibly have. And the way that would happen is if you had only single bonds. So here's how we name these. We use prefixes and then add ane at the end. And here's the prefixes we're going to use. Okay, meth always means it has 1 carbon. So if we said methane, that means it's a single carbon organic molecule. Eth means 2, that's ethane. Prop is 3, propane. That's not but, it's butane. Okay, so let me back up. Propane would be in barbecues. Methane is a primary component of a natural gas. Butane's in lighters. We got pent, hept, oct, non, and deca as in decade. So those are all the prefixes we're going to use for these. So there's some of them. There's methane, ethane, propane, and different forms of butane. So you're going to practice with a few of those. So you need to be familiar with those prefixes and then try to start memorizing those. There's also something called cycloalkanes. So this one has 3 carbons. So therefore the prefix for 3 is prop. And all 3 carbons are connected. They're not just in alliance. We'd say cyclopropane. We have cyclobutane, cyclopentane, cyclohexane. All right. So there's also some things called alkyl groups, and these are chains that come off of the main carbon chain. And I'll show you how to identify the main carbon chain. But the nice thing is we use prefixes for those as well, and they're the exact same prefix. So if we have a methyl group, that means we have a single carbon coming off the main chain. If we have an ethyl group, 2 carbons coming off the main chain. So let's go ahead and show you how to name some of these. Okay, so let's start with this. Here's how you name a compound. Okay, so first of all, let's identify the main carbon chain. It's the longest continuous chain of carbon. It doesn't have to be straight, but just attached. So right here, we have the main carbon chain. And then we've got some carbons coming off of those. So this main carbon chain is the alkane group, and it's 8, so it's going to be octane. And then we have some other side groups coming off there. We have a single carbon. And if we look over here, the name for single carbon is meth. And we would put the YL ending on it. So that would be a methyl group. We have 3 methyl groups on here. Okay. Then we also have a 2 carbon coming off of the main carbon chain. And that's an ethyl group because eth is the prefix for 2. So let's go ahead and name this. Basically, there's 2 parts to the name. I'm going to draw my line, and the part on the right is the name for the main carbon chain. Okay, and that one is going to be octane. Okay, that's our main carbon chain because it's got 8 carbons. Notice it ends in ane. And then we need to go ahead and all right, so now what we need to do is identify which side chains we have on there. We know we have 3 ethyls. 1, 2, 3. And we have 1 methyl. 3 methyls and 1 ethyl. Okay, so we got 3 of those, we got 1 of those. All right, so here's how you name these. We have to decide a couple things. First of all, we have to decide which carbons are where are those side chains located. Okay, so we need to tell which carbon of the main chain they're attached to. So here's what we do. We need to number our main carbon chain. So we could start numbering from one end or the other. Here's the rule. You want to start numbering so that your alkyl groups, your side chains, are at the front of the molecule. Okay, so we want to start numbering here. 1, 2, 3. We're numbering the main carbons of the carbons of our main chain, and that's where we got the octane. Okay, you don't want to start numbering the other direction. Okay, because as you'll see in this instance, we have our first side chain on the second carbon, and so we have our first side chain on the second carbon. If we started this direction, it would be 1, 2, 3, 4. We wouldn't have our first side chain until the 4th carbon. Okay, so that's how you decide where to number. Okay, I have 2 choices, which side. All right, so now we need to go ahead and identify, finish our name. So on the left side of the name, okay, those are the side chains. Okay, so we have we have 3 methyl groups and 1 ethyl. So how do you decide which goes first in the name? Well, it's really scientific. Wait for it. Alphabetical order. So E, ethyl, always comes before M in the alphabet. So if you look over here, if you have a butyl group, that's always going to be listed first. Okay, so it's alphabetical order, pretty simple. So we need to say, so we're going to start with the ethyl group, and we need to say where that ethyl group is located. It's located on the 3rd carbon. So we're going to go 3 ethyl. Okay, that just took care of our ethyl group, so that one's done. And then we have 3 methyl groups. So we have it at the 2nd, the 4th, and the 5th carbon. So 2. Oops, there should be a dash there. 2, 4, 5. So that's saying we have 1 here at the 2nd carbon, the 4th carbon, and the 5th carbon of our main chain. And then we need to be really redundant. Even though you can see there's 3, we need to say trimethyl. All right, so that gives us 3 ethyl, 2, 4, 5 trimethyl. Okay, and don't worry about the punctuation and whatnot. Not a big deal. But there's commas in between here, and there's some dashes. So 3 ethyl, 2, 4, 5 trimethyl octane. All right, good luck.